Hi, my name is Peter Bello and I'm an applications engineer with Arrow Electronics. Today we're going to take a look at a wireless charging solution from Texas Instruments. We will be evaluating the performance of the BQ500215 wireless power transmitter and the BQ51050B wireless receiver and battery charger. Here is the evaluation board for the BQ500215 transmitter. The BQ500215 delivers up to 5 watts to a Qi compliant receiver. Additionally, it can output 10 watts using a non-standard implementation. This is the evaluation board for the BQ51050B wireless power receiver and battery charger. This is unique because it incorporates both functions, wireless power receiving and battery charging, into one integrated circuit. When coupled with a wireless power transmitter, this will supply up to 1.5 amps of charging current to a single cell lithium-ion battery. For this demonstration, we are going to need one additional circuit, a battery emulator. This is called out in the user guide for the BQ51050B receiver and is simple to build. Rather than connect up an actual lithium-ion battery and wait for it to charge, for testing purposes, we can speed up the process using this circuit. Let's get started. Here we have the BQ500215 transmitter board with no receiver connected. It's hooked up to a 12-volt power supply. What we see here on channel 1 of the scope is the output of the transmitter coil. Channel 1 of the scope is monitoring TP3 on the eval board. During what's known as the selection phase, it sends out an analog ping or pulse every 400 milliseconds or so. Here the scope is set to 10 volts and 100 milliseconds per division. Channel 2's probe is connected to the receiver coil on the BQ51050B board. We are looking at test point 4, TP4, on the receive evaluation board. Since the receiver is not being powered, there is no output. Now we'll put the receiver on top of the transmitter and align the two coils. As we can see now on the scope, power is now being transmitted. Time base on the scope is set to 2.5 microseconds per division. We can see that the period is about 3 divisions, so that means 7.5 microseconds. Take the inverse of 7.5 microseconds and you have about 130 kilohertz. Now let's see what happens when a foreign object is inserted between the receiver and the transmitter. We'll use this quarter. The receiver is communicating with the transmitter, telling it how much power is being received. The transmitter compares this with the power transmitted. If there's a big difference, it determines a foreign object is present and it terminates the power transfer. This can take about 10 seconds. As you can see by the red LED on the eval board, the quarter has been detected. Now we are going to observe the battery charging functionality of the BQ51050B. Before we do this, let's briefly look at the charging profile of a lithium-ion battery. The blue dashed line represents the battery voltage and the red solid line the charging current. When the battery voltage is below a certain threshold, V low V in the figure, it is charged at a reduced rate. This is known as the pre-charge phase. Once the battery is charged up to the threshold voltage, it can be charged at an increased rate. This is known as the fast charge phase. A constant current is supplied to the battery and the voltage across it is monitored. The third phase is known as the constant voltage phase. Once the battery voltage reaches its targeted maximum, which is about 4.2 volts for a single cell lithium-ion battery, charging current is reduced to a certain level, then terminated. For this demonstration, we are going to use a battery emulation circuit in place of the lithium-ion battery. The way it works is this. A power supply is connected between the anode of Schottky diode D1 and ground. Current from the power supply flows through resistors R1 and R2, setting up a voltage across these resistors, then back to the power supply ground. The battery charging IC senses the voltage across BAT plus and BAT minus. This voltage is simply the voltage across R1, R2 plus the small IR drop across the current sense resistor R3. By varying the power supply voltage, we increase the drop across R1, R2 and consequently the voltage across BAT+ and BAT-. This will allow us to observe all three charging phases as well as the charging current. The battery emulating voltage is set to 2.1 volts, as you can see on the DVM. Since the pre-charge threshold voltage for the BQ51050B is 3 volts, charger is in pre-charge mode. As we saw with the lithium-ion charging profile, this is a reduced current stage. The ammeter is connected in series between the battery emulator and the charger. As you can see on the ammeter, the current is about 192 milliamps, going from the wireless power charging circuit to the battery emulator. Now let's look at the scope. The upper trace shows the transmitted voltage waveform. The lower trace shows the received voltage. The scope is set to 10 volts per division for both channels. As you can see, the voltage peak to peak on the received power is about 10 volts. Now we'll increase the voltage across the load to put the charger into fast charge mode. As we can see on the ammeter, charging current is about 1 amp of current. Looking at the scope, the bottom trace, the received voltage level has increased as well, from about 11 volts peak to peak to about 26 volts peak to peak. Now let's increase the voltage across the load to 4.1 volts. This corresponds approximately to the onset of the constant voltage mode of operation. As we can see, the charging current is reduced to 420 milliamps or so. Also, as you can see on the bottom trace in the scope, the amplitude of the received voltage is about 14 volts peak to peak. So there you have it. We've seen how the BQ500215 wireless power transmitter and the BQ51050B receiver work together to give you a complete Qi-compatible wireless battery charging solution. Thank you for joining us. For more information, contact your local Arrow Electronics representative.